For number 20, let's start with f of g of x. My f function is the square root of x, and inside where the x was, I'm going to put in g, which is 2 minus 3x. I'm going to remove my parentheses because they're not needed. I only put them there to show you that's where x used to be, and that's where I'm substituting into, so you can just take those away. And now I'm going to go ahead and find the domain. First, I'm going to look at the domain of my composite function that has a radical symbol right there. And if you have a radical, you are going to take the radicand underneath and set that greater than or equal to 0. And then I'm going to go ahead and subtract 2. I get negative 3x is greater than or equal to negative 2. I'm going to divide by negative 3, and when you divide by a negative with an inequality, it reverses the inequality symbol, so I have to switch that around. And then you get x is less than or equal to 2/3. So I'm going to shade that over here. And then I just want to make sure I bring in any domain restrictions from g of x that I might have lost somewhere along the way. So g of x has a domain of all real numbers. There are no additional restrictions. My domain is straight up. X has to be less than or equal to 2/3. So that is going to be negative infinity up to 2/3 with a bracket. Now let's go ahead and do g of f. That's my g function with f of x substituted inside. And my g function is 2 minus 3 times x. And in for my x is going to go f of x, which is just the square root of x. And then my composite function simplifies to 2 minus 3 root x. And then we need to find the domain. So if I look at the domain of my composite function, I see I have a radical symbol in there, and you have to take what is in the denominator and set that greater than or equal to 0. And when I solve it, it's like already solved. I don't have anything to add or divide by. So that's the domain of my composite. And then we just need to make sure we look at the domain of the inner function separately. And the domain of my inner function up here, which is the square root of x, has to be handled or looked at. In the square root of x, you're going to figure out what makes your radicand greater than or equal to 0. So I'm going to take my x, that's underneath, set it greater to equal to 0, and that's done. That's the domain of my inner function. Now the domain of my composite and the domain of the inner function are twins. So there's no additional domain restrictions. And therefore the domain of my composite function is going to be from 0 to infinity.